This is a video for AQA Further Pure Mathematics, Matrices section 3.2, finding minors and cofactors of a 3 by 3 matrix. Before you proceed with this video, make sure that you do already know how to find the inverse of a matrix using your calculator. That is important. However, there are times when you won't be able to use a calculator. For example, questions may involve algebraic terms in the matrix, and therefore that rules out the use of a calculator. So we need to know how to find the inverse of 3 by 3 matrices. We already have a method for 2 by 2 matrices, of course, and now what we want to do is to see how we can develop the ideas to produce the inverses of matrices of higher order. Well, throughout we'll be using this notation, which is quite a nice one because it allows me to refer to elements easily. You'll see that each of the columns is labelled by letters. We've got A, B and C, and the rows 1, 2 and 3. So obviously B2 refers to second column and second row. To find the inverse of M, we need to be able to do several steps. These will develop through the next couple of videos or so, but to show you what the steps are before we start, we need to find cofactors of each element, and then also the determinant of M, and set up what's called the adjoint of M, so that we then have that the inverse will be the adjoint divided by the determinant. Now in practice we tend to find the determinant first, because obviously we have the idea that if the determinant of M is equal to 0, then this is a singular matrix, and therefore no point in trying to find its inverse because it doesn't exist. So you can see there are several steps involved, so we're going to break this down into smaller parts and develop the ideas as we go along. Well, the first thing we need to define is what we mean by the minor of an element. So by the minor of an element, we eliminate the row and the column containing that element. So for example, if we were to find the minor of A1, which is that element there, we would start off by eliminating that row and column. That leaves us with a small sub-matrix, if you like, and we can find the determinant of that little part there. So the minor of the element is the determinant of that 2 by 2 matrix. So the minor of A1 is the determinant of -3, 7, 4, 2. And of course that's equal to -6 minus 28, which is -34. So every element in the matrix has a minor which is found in exactly the same way as that. Eliminate the row and the column, and then find the determinant of the 2 by 2 matrix which is remaining. The cofactor of an element is the minor and then a sign applied according to the following pattern. Now you'll see that that pattern is quite symmetric. It starts off with positive for A1 and then goes positive, negative, positive and so on throughout the rows and columns. So we found that the minor for A1 was equal to -34, and because we're applying the positive there, we can see therefore that the cofactor of A1 is also -34. If we looked at B1, however, so that B1 is this element here, and what we need to do is to eliminate the row and the column and find the determinant of the little matrix. So the determinant of -5, 7, 6 and 2, that's equal to -10 minus 42, so that's -52. So that's the minor, and therefore the cofactor of that element, well, we check the sign that we need, and we need a negative sign. So therefore the cofactor of B1 is equal to plus 52. The notation that we use for the cofactor is a capital letter corresponding to the element itself. So you see the cofactor of B1 is given the symbol capital B1. C2, for example, so C2 is this element here, and you can see that we've eliminated the row and the column, leaving the determinant 3, 2, 6, 4, which is equal to 0. The cofactor of C2 is therefore equal to 0. What I'd like you to do now is to pause the video and just try working out a few of the cofactors for this matrix M. Well, here are all the answers. So we'll just have a quick look at one or two of them. Perhaps let's say, for example, we look at C2. So C2 would come from this one here, eliminating the row and the column, gives us a matrix 1, 2, 1, 0, and that has determinant equal to negative 2, but for C2 we've got to apply the negative sign here, which is making the cofactor for that element equal to 2. Well, if all you want to do is to find the cofactors, then there is an alternative method, which means that you don't need to write out all of those little determinants. What you do is you take the matrix M and then alongside it repeat columns 1 and 2. So here we'll have 1, 0, 1 and then 2, 4, 0. If then underneath that you write the first row and the second row, so 1, 2, 3, and include the 1 and the 2, and the second row 0, 4, 5, 0, 4, we then have a much larger matrix, but we ignore the first row and the first column, and then the cofactors are produced by the determinants at each of these positions. So this one here will give us the cofactor for A1. So you can see that A1 has got determinant 24, so A1 equals 24. If you then move along one step, we're looking at this block here, 5, 0, 6, 1, the determinant of that is 5. So B1 is equal to 5. Notice that the signs that we had to deal with in the previous slides are handled automatically by this method. So B1 is just the determinant of that little block there. C1, we can move along again. So C1 is negative 4. And again, the negative sign is handled for us. So there we have all of the cofactors for the matrix. And notice, for example, I've just illustrated there that the determinant of that one there is 10 minus 12, which is negative 2. So A3 is negative 2. Well, that concludes this video on minors and cofactors, and in the next one we'll be looking at how we use those to find the determinant of a 3 by 3 matrix.